This is the zero product property. Example 1. X squared plus 4x equals 0. The first thing you need to do is factor x squared plus 4x. Try taking out something common. Oh yeah, it'll factor into x times x plus 4. Well, the zero product property tells me that the only way I'm going to multiply and get 0 is if I have 0 in my problem. So either the x has to be equal to 0, or the x plus 4 portion has to be equal to 0. Well, if x equals 0, then x equals 0. There's nothing to solve. But on the right-hand side, if x plus 4 equals 0, in order to get the x alone, I'm going to have to subtract 4 from both sides, which means that for that answer, the x could be negative 4. So I have two answers, x equals 0 or x equals negative 4. Here's another example of the zero product property. This time, let's look at x squared plus 6x plus 8 is equal to 0. Can I take out something common? No. Is it a difference of squares? No. Is it a perfect square trinomial? No. Must be the other type of factoring. Is it the easy kind or the hard kind? Oh, there's no leading coefficient. This is the easy problem. So now, is it rule 1, rule 2, or rule 3? Oh, it's a plus plus. That's rule 1. That means both of my binomials have to be addition. How can I multiply to make 8, but add to make 6? 1 times 8 would make 9. 2 times 4, oh, that makes 6. So apparently this factors into x plus 4, x plus 2, and that equals 0. Again, the only way to multiply and get 0 for an answer is to have 0 in the problem. So either x plus 4 is equal to 0, or x plus 2 is equal to 0. Set up your two equations. How do I get rid of a plus 4? Well, I would subtract it. How do I get rid of a plus 2? I subtract that. Doing the math on each of the equations gives me final answers of x being equal to negative 4 or x is equal to negative 2.